Finish up with section 4.4, which is on angle side angle and angle side congruence postulates and theorems. One's a postulate, one's a theorem. Okay, so yesterday we used side and side angle side. Okay, today we're going to learn two more ways. And again, these are just shortcuts from having to go back to the definition of congruence. So we don't have to show every single angle and every single side. Okay, that's a little bit of like overkill. Okay, too much work. You just have to show one of these four postulates or theorems. All right, so let's start out with angle side angle. Okay, angle side angle is a congruence postulate. Okay, postulate, what does that mean? We don't have to prove it. Okay, it's just something that's accepted. We kind of use it as a building block to prove other things, but we don't have to prove it. Okay, you have to have some things in geometry that you don't prove that are building blocks for other things. All right, so if you've got two angles and the included side, included means between. All right, so if you've got two angles in a triangle that are congruent, and the side that connects those two angles, the side between them, is also congruent to a second triangle, then your triangles are congruent. Okay, so there's a picture of angle side angle congruence postulate. Okay, angle A is congruent to D, angle C is congruent to F, and the included side, the side that connects the angles, AC, is congruent to DF. Okay, so what would be one way you could write a congruence statement? Triangle what is congruent to triangle what? And there's 6 different ways you could do this. Denver?
ABC is triangle ABC.
Yep, triangle ABC.
Versus triangle D.
Yep, good. So he went from the one with one tick mark, one curved mark, no curved marks, and then 2. So do the same thing in the other triangle. 1, none, 2. Okay, the next one we're going to look at is angle side congruence theorem. Okay, so you might be looking and be like, well, what's the difference? Didn't we just do one with 2 angles and a side? Yes. The one above it is 2 angles and a side. So is this one. The difference is where the side is. Is it the side between the 2 angles? Or is it a side that's not between? Okay, so in this one it says if you've got 2 angles and a non-included side, a side that is not between the 2 angles. So 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side in a different triangle, then your triangles are congruent. Okay, let me show you the picture of this. Let's see if we can get both pictures up at the same time. Okay, so there's the difference. Okay, the one on the bottom, you've got 2 angles, say A and C, but this time the side that you know isn't the side that connects the 2 angles. It's one of the sides that doesn't connect the 2 angles. So A matches up with D, C matches up with F, and then segment BC and EF match. Any question on the difference between the two, postulate and the theorem? Yeah?
Shorty, what you have it is basically if you have 2 angles and a side, you're good.
Yep. No matter how you arrange it. If you've got 2 angles and you got the side between or not between, it works. Yep. So now we've got four ways to prove triangles are congruent. 2 angles and a side, any way you want. Side, it's all three sides, or two sides and an angle, but that one does matter. If you've got two sides and an angle, it's got to be side angle side, not side side angle. Okay, we talked about that. Okay. Any questions on angle angle side congruence theorem? All right, so I think first thing we'll do is prove that theorem. Okay, and you can prove it using any of the other postulates we already have. Side, 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 angle, or angle, side, angle. Those are all postulates. And in fact, we will. We'll use one of those to prove this one. All right, so I'm giving you a diagram. I didn't write down what was given, but I marked it. Okay, marking it in a diagram is just as good as writing it down. Okay, let's start out with our first statement. Okay, based on that picture, think about what you usually start with in a proof. What has been marked here? Let's write down some of that stuff. Yep.
Angle A is congruent to angle D.
Yep, angle A is congruent to angle D. All right, now we've said something about angles being congruent. We're probably not going to use side, side, side. Why would you waste your time saying something about an angle if you're going to just use all three sides? Okay, so we should be thinking along the lines of something with an angle. Okay, what else can we say? We'll put it under statement one. Yep.
Angle C is congruent to angle F.
Okay. Angle C is congruent to angle F. And somebody else give me the last thing that's given there. Yep.
Side BC is congruent to side EF.
Yep. So segment BC is congruent to EF. Okay, that's all given. Now, after we prove this theorem, that's going to be enough information. But right now, we haven't proved the theorem yet. Okay? Is there anything else I can say? Something we've learned about triangles. Not sure you're going to be able to do much else with sides here. But there is one more thing you can say based on what was given. Is it? Yep.
Can't you say that angle E and angle B are congruent?
Yes. You can say that angle B is congruent to angle E. What's the reason for that? We had a name for this. And it was a theorem. It's 3 words. Yep.
Three angle theorem.
Yeah, the third angles theorem. Third angles theorem says if you've got 2 angles congruent, then the third ones have to be, because they all add up to 180. Okay, so that's the third angles theorem. So let's mark that in a different color. Okay, so now looking at those triangles, what do we have now in terms of information that might be able to help us? Anybody see one of our postulates we've already learned that we could use now? What is it? Angle is not a congruence postulate. Again, think of like an equilateral triangle. Like I said to Denver, with all 60-degree angles, you could have larger or smaller versions, but all the angles would stay 60. But that does prove similarity, meaning one could be a smaller version of the other. Yeah, we've got angle, side, angle. And if we go back, angle, side, angle, that was a postulate. We don't need to prove that. We can just use it. So now we can say the triangles are congruent. And angle, side, angle will be the reason. So triangle ABC is congruent to, so we went 1, 3, and then 2 tick marks, so do the same thing over here. 1, 3, 2. DEF. In this case, the letters happen to be in alphabetical order. That doesn't always happen. So you got to match up corresponding parts. Okay, and what was our reason? What postulate? Yep. Angle side angle congruence postulate. All right, now that we've proven angle side, we can use angle side as a reason. We do not have to prove that one again. All right. So in these pictures, we don't have to prove anything. I just want you to look at the picture and tell me, is it possible to prove the triangles are congruent? If it is, tell me which of the 4 postulates you would use. Okay, so let's take a look at A. Do you have enough information there to prove those triangles are congruent?
Yes.
You have one angle.
You've got, well, you can do is, you only know 2 angles, 2 sides are congruent, right? And you got the alternate interior angles are congruent. And you know, so that like that point on G, those 2 outside angles, they're vertical angles?
Yes, they're vertical. So that's the key, they're vertical. I knew which angles you were talking about. Just be careful because these weren't marked as parallel, so we don't have alternate interior, unless we know we have parallel lines.
Right.
But yeah, I knew you meant FEG and HJG. They're marked.
And you could say that that's, since the vertical angles are congruent.
Yep.
And
So what theorem now?
whatever, AAS.
Yep.
Postulate would be,
Yep, angle side, that one's a theorem. That's a theorem. So we've proven it. By angle side, these 2 triangles are congruent. Okay, you don't have, I'm sorry, we haven't proven it, but that's what you would use to prove it. You just have to list out the angles, the side, and the other angle. Okay, any question on that one? Could you use side here? No? Not unless you knew something about, like, if EJ and FH bisected each other, then I think you could do side, but we don't know that.
We would also need that FE and JH need to be parallel to that.
Well, if we knew they were just bisected, that would automatically mean this matches this, and it would automatically mean that matches that. If they were bisected. Now, maybe that would mean that we have some parallel sides somewhere, but we wouldn't need to know parallel for that. If you did have parallel, though, that could help you with alternate interior angles. Okay, maybe you could do something with that. So depending on what you're given, there's different ways to go about it.
they're marked as congruent.
They're marked as congruent.
Doesn't that mean that those lines, like, they have to be parallel? If they're alternate interior and those lines are congruent, that means those 2 lines have to be parallel.
Well, just because they're marked congruent, it doesn't mean they have to be parallel. They could be, we could sketch different diagrams that they might not be parallel, even though they're congruent. It is possible. So think about if you had a line like that. And again, this is going to be a slightly different diagram, but a line like that. Turn it a little bit. Okay, they are congruent. So now if I make triangles, but they're not parallel anymore because one of them's turned a little bit. Okay.
You always know what to say.
Well, I try.
Seems like you do this for a living.
I do. Okay, how about that one? A good thing might be to at least mark down anything we know by looking at the picture. That might help us. Is there anything that I can add to this by looking at it that's congruent?
NP.
Yeah, NP is congruent to NP. because that's reflexive. So we've got a side, we've got a side. We don't have any parallel lines marked here. So we can't do anything with alternate interior angles. So do we have enough information? No. You cannot prove these triangles are congruent. You've got side, side. You'd need an angle, or you need some, or another side. But as it is right here, no. That cannot be proven congruent. Okay, how about this one? Now we've got all kinds of things here. We've got parallel lines. Nothing's marked as congruent. But what do we know based on those parallel lines? We know a few things. Yeah?
1 and 3 are congruent.
Yep. We know 1 and 3 are congruent. Okay, somebody else tell me what else? Yeah.
4 and 2 are congruent.
Yep, 4 and 2. Okay, that's all because of parallel lines cut by a transversal.
And that line is,
And what else do we know? One more thing.
that transversal is congruent to itself.
Yes, the transversal is congruent to itself. Actually, we don't need 3 tick marks. We just need 1. So what reason do we have there? So if we say angle, angle, side, that means the side is not connecting the two angles that are congruent. In this case, it is, though.
Angle, side, angle.
Yeah, we have an angle, a side, and an angle. The side is between the two angles. Okay, so angle, side, angle. Right, any questions on that one? So part of what I might ask you to do is determine whether or not you can even prove two things are congruent. Maybe not do the proof. Okay, just something like that. Okay, now we'll try a proof. All right, so I've marked in the diagram AD and EC are parallel. BD is congruent to BC. And that's it. Prove that triangle ABD and EBC are congruent. Okay, what would be a good thing to start out with? Okay, you could start out with something like that, but before you do that, you got to say that you have parallel lines.
In the midpoint.
And you could say that BD is congruent to BC. Yes, that does prove B is a midpoint, if they wanted to know that, but I don't think we're going to have to say that. But that is true. B is a midpoint.
Vertical angles.
Yep, we do have to say something about vertical angles too. So let's start with what was given. AD is parallel to BC. Now by saying that, you can talk about alternate interior angles. But you got to say this first. Okay. What else did they give us? BD and BC are congruent. And what's the reason for all that?
It's given.
It's given. Okay, so when I look at this picture, since I see parallel lines, what kind of angles are we maybe going to start to think about? Alternate interior. So right away, I'm not thinking side, side, side. I'm not going to be able to show all the sides are congruent. Okay, I don't have enough information for that. But I do know something about alternate interior angles. Okay. Somebody give me one. It can be a little tricky to figure out, but what are the alternate interior angles here?
E and A.
Yep, and you can name them with a single letter. There's no confusion. Okay. Angle A and angle E. Those are congruent. Two parallel lines cut by a transversal. So angle A and E are congruent. Alternate interior angles. Okay, so now we've got a side matching a side. We've got an angle matching an angle. We need something else.
C and D are alternate interior angles.
Okay, so we could talk about, let's see. Sure, you could talk about C and D.
We could do angle and side.
Yep, we could do it that way. What's another way we could do it?
Well, I would just like to point out that AD and BC are not parallel.
AD,
And BC are not parallel, you said they weren't. From the statement.
oh, in the statement? Oh, thank you. I meant to AD and EC. Thank you. Yeah, try to make sure you copy down what was given. Yes, thank you. All right, so what's another, so Connor said something about using alternate interior angles again. Sure, could do that. What's a different way? You could do vertical angles. All right? Either way, I think you're going to end up with the same reason. If you do the vertical angles, you're going to end up with angle, angle, side. If you did alternate interior again, you'd have angle, angle, and a side. It's going to end up being the same reason either way. Okay? So this is one of our first proofs I think we've had a choice of how to do it. Okay? So you had a little bit of an option there. When I name the vertical angles, I have to be more specific than B. That would be confusing. So we could say angle ABD is congruent to angle EBC, if we're going to be consistent. Yep. Those are vertical angles. And finish up with the statement they wanted you to prove.
So there's two ways of doing this.
There's more than one way. Yep, at least two. Triangle ABD is congruent to, was it EBC? Reasons? We have angle, angle, side. That's the reason. Okay, you can just write the three letters, angle, angle, side. Okay, so most of these triangle proofs, they're not very long. Sometimes they're between 3 steps and 5 steps, most of the time. Okay, especially if you combine the given information into one statement. Okay, let's try this one. Yeah, I think this will be our last one. All right, so this time they've marked angles B and C congruent, D and F congruent, and then they've said something about a midpoint. M is the midpoint of DF. So definition of midpoint is probably going to come up here somewhere as a reason. Okay, prove triangle BDM is congruent to triangle CFM. Statements and reasons. Okay, what could be, Selena, what could be my first statement here? Sure, that's going to be an important part of proving the congruence postulate. Angle B is congruent to angle C. Okay? Anything else I can say that I can lump in with the same reason? Yep.
Angle D is congruent
Angle D is congruent to
to angle F.
angle F. Jacob, what would be my third statement under that first reason? Yep, so M is the midpoint of segment DF. Since that's all given, let's just put it all in the same statement. Midpoint of segment DF. Okay, as far as saying angle B is congruent to angle C and angle D is congruent to angle F, that's pretty much all you can say with those statements. But the midpoint one, we have to come up with another fact from that.
DM is congruent to FM.
Yep, DM and FM. So he said that in exactly the right order. DM congruent to FM. What's the reason?
Congruent.
Yep, but why are they congruent? Definition of midpoint. Good.
That's your definition of midpoint.
Yeah, that's what I need to.
Okay, let's mark that. Do we have vertical angles in this picture?
I don't think so.
No. Vertical angles, you have to have an X shape.
But
So we don't have any vertical angles, but do we have enough information?
BMD and angle CMF congruent to the other.
We don't know those two angles are congruent.
Right.
Well, actually, you're right, we do. What would be the reason if you wanted to say that? You could. We said we used this in an earlier proof. I don't think we're going to need this because I think we already have enough information. We're done. But what would be the reason? You could. If you wanted to use the third angles theorem, you could say those angles are also congruent. And that would allow you to prove this with angle, side, angle. But,
Or angle, angle.
yep, angle, angle, side, I think we're done right here. We don't need to talk about that third angle. We don't need it. Okay, so finish up your proof. Triangle BDM is congruent to triangle CFM. Just stick with the same order they gave you up above. And the reason? Angle, angle, side. Okay. So again, sometimes more than one way to prove it, but try to stick with the simplest way, the shortest way. That's usually what we're looking for. Okay, so the homework is on page 223. 8 to 13 all, 14, 16, 19 to 22 all, and 35 and 36. Okay, so tomorrow we'll take a look at section 4.5. That'll be our last section for the week, and then we'll have our test on Friday.